So far, these are the three ways that we can prove triangles are congruent. Okay, we've gone side, 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 angle, side, angle, side, angle. I'm gonna give you two more right now to round out the way, all five ways that we can prove two triangles are congruent. And the way that we can do it, this next one is called this: angle, angle, side theorem. So that stands for angle, angle, side. Theorem. Yeah. Yeah, summary theorem, postulate theorem. Angle, angle, side theorem. Alright. So, yeah, no problem. Okay. Again, this is going to be an if-then statement. And we already know what the then is going to be, right? What's the then part going to be? Then the two triangles are congruent. Good. Then the two triangles are congruent. Okay. So for angle, side, angle, take a look at what the picture is going to look like. Angle, side, I'm going to have an angle, or sorry, angle, angle, side, excuse me. Angle, angle, side. So this is what I'm looking for. Angle, angle, side. Angle, angle, side. That's what we're looking for, okay? That's what it looks like. Angle, angle, side. You got to have two angles in a row and then an alternate and then a side. Two angles in a row and then a side. That's angle, angle, side.
Doesn't matter which side.
They're just to be corresponding, right? That's the only thing. The caveat here is that they always have to be corresponding. So the if is this: if two angles and the non-included side. So what do I mean by that? Two angles on the non-included side.
It's not inside.
Exactly. So notice I have this angle and that angle. The included side is the one between them. And that's not the one I'm talking about, because that'd be angle, side, angle. I'm talking about the non-included. So I'm either talking about that one there or the one across from it. So the non-included side. Doesn't matter, as long as it's corresponding. As long as it's the non-included side. So two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. Alright, so once we have the given set up, we're going to make sure we put everything that we know onto the picture. So what do we know so far, you guys? Angle M is congruent to angle K. So this angle here is congruent to that angle there, and that's definitely an angle, so I'll go ahead and put an A there, because I'm trying to figure out which one I'm going to use, right? It's got to be one of these here. Alright, what else do I know? WM are parallel. Okay, so that means that I could put this in here, and I could put this in here. That's all that I know.
Why did we write a transversal in the middle? You don't know that's a transversal.
Well, that is a transversal now. Yeah, because we have two parallel lines, right? Okay. Okay, you guys. Because they're parallel, is there an angle I could get? Do you see an angle I could get?
Yeah.
What angle do you see?
W.
W. How about M, W? Nope, not that one. MWR. So could I get this angle here? MWR has to be congruent to what? I don't know why that keeps coming up. MWR has to be congruent to KRW. This one here. KRW, okay? So that's an angle. Wait, what's the reason for that? Why is that true? Because those are alternate interior, right? So far I have angle, angle. Angle, angle. It'd be great if I could get a side somewhere. Anybody see a side anywhere? That common side. Very good. The WR. So this one right here. So that one, that's going to be a side. So what is going to be our plan for this, you guys? AAS stands for what? So we have a plan to do angle, angle, side. I always like to write my plan down to say, okay, this is the plan for the proof, is to prove angle, angle, side. If I can show angle, angle, side, then is that enough to show that those triangles are congruent? Exactly. Okay, so let's get our...
How would that be angle side
Because I have two angles and the non-included side. Two angles and the non-included side. That's why I know it. Okay, number one, what are we going to write down, you guys? Angle M, congruent to angle K. That is an angle, isn't it? And what else do I know?
WM is parallel to
Oh, I shouldn't put number 2 there, sorry. Put WM
is
parallel to RK. Good. And all of this information is what? All of it is given. Very good. And then somewhere down the line here, I don't know where, but I'll just extend my line here. Somewhere down here, I'm going to be able to say that triangle WMR is now congruent to triangle RKW. And what's my plan going to be in this case, guys? Yeah, angle, angle, side. Now I actually know the plan. So I can actually add that in now, huh? Okay, I'm going to shrink this down so we can see it all. Okay, there we go. Okay, I have the angle. What else do I need? I need another angle. So what's it going to be? Angle.
Angle WM is
No.
parallel to
No, I know that WM and RK are parallel. I just said that. It's given to me.
Oh, it's
MWR
There you go.
is congruent to R
Nope.
AM
Nope.
no R
KRW.
KRW.
So think about it. Look what I'm doing. Look. M to W to R. So I have to go K, R to W. That's the corresponding angle. Okay? Now, why is this true? Why is this true? I can't just make statements without any reasons. Very good. Alternate interior angles are congruent. Very good. Alternate interior angles are congruent. So I just proved another angle. So far I have the angle part, I have the angle part. Now it would be great if I could prove the side part. So what am I going to say?
WR is congruent to W.
Very good. WR, or Elijah, if you'd like prefer, RW. WR congruent to WR. And why is this true?
Reflexive.
Because it's reflexive. Okay? And that's a side. So, ladies and gentlemen, look what you have shown. You have proven an angle and angle on the side. Do you have enough information now?
Yes.
Yes, you do. What are you going to say? 4. So, number 4, and we're done. Okay, so here's our example. We have all the information set up. Let's go ahead and decorate the picture. So, what do we know? Angle N, congruent to angle S, and that's an angle, isn't it? So far, I have an angle. That's good news. Okay. What else do I know? Ooh, I have, this angle here and that angle there. That's going to be another angle because they're vertical. So far I have 2 angles. So therefore, it's not going to be the first one. It's not going to be side, side, side. Okay?
Or the second one.
Yeah, or the second
Or the second one. There you go.
Or the third one.
No, there could be 2 angles.
Okay.
No, but there's no side in between. There's 2 angles on one.
Okay, Elijah, why do you say angle on the side, buddy?
Because there's 2 angles on it.
Okay, well, where's that side going to come from? What's the side?
L.
No, L's a line.
Q.
What do you know about L?
And 2.
What do you know about L? Tell me something you know about L.
It bisects and makes a midpoint.
Yeah, it bisects TR at point Q. So that tells you that this line segment and this line segment are what? Are congruent. Therefore, my plan is going to be what? What do I have? I have 2 angles and a non-included side. Therefore, it looks like my plan is going to be angle, angle, side. Do you see why it's important to make a plan first?
But I'm not sure how PQ and
Good plan. Okay, so number 1, here we go. Angle N, congruent to angle S. That's an angle. And what else do I know? L bisects TR at Q. And all this information is given to us. So somewhere down here, I'll move this up a little bit. Somewhere down here, what can I say?
The other given one.
angle.
Triangle NQT, congruent to triangle what? And what's our plan going to be?
To get AS.
Angle, angle, side. That's our plan. Okay, good. Now that I have all that, I'll shrink the picture.
So now
So-
our minimum could be 4 instead
There you go. Look at that. As long as you have that plan. Yeah. So moving along, number 2. We have the first angle. What's the next thing we want to get? That second angle. So how about angle? Wait, angle A? There's no A on the page.
NQT.
NQT. Look at that angle. NQT. That corresponds to what? No.
RQS.
No. SQR. What do you mean? Okay, and that's because vertical angles are congruent. So far I have angle, angle. What do I need, you guys?
The side.
I need the side. What am I going to say?
TQ's equal.
TQ, congruent to RQ. Very good. And that's a side. And the reason is because what?
Bisect.
Very good, Ben. The definition of bisect. That's not an angle bisector. That's a segment bisector. Definition of bisector. Okay, there you go. Do you have enough? You should. Check it out. You have an angle, you have an angle, you have a side. So therefore, you can say this statement now. Biangle, angle, side. And so we're going to do that, and then we're going to do that. Okay, this is a you try. I want you and the person next to you to work together. Everyone does their own work on their own proof page. I've given you the given, the prove, the drawing, and then the statement and the reason. Okay, you are supposed to now take the information and mark up the drawing correctly, and then see if you can create a plan. It's going to be one of these 4 ways to do it, and then execute the plan. Okay, so we have all the information on the page. Then you should have then marked up the drawing. So angle V is congruent to angle Y. So this one is congruent to that one. That's an angle. You guys agree with that? Okay, so far we have an angle in play. Then what can we say? What else do we know? Yeah, Ashley, in the back. What do you got? Yeah, so you know that VW.
VWZ.
Yeah, so WZ bisects angle VWY. So this one up here. So you know this angle and that angle are congruent. Is that true? Okay. And that's an angle, right? So far I've got 2 angles, right? What else can I say now? That's the common side. So this side right here is with itself. So what's our plan going to be, you guys?
AAS.
Angle, angle, side. So our plan is going to be an angle, angle, side. So down here, we're going to put angle, angle, side. Okay, do we already have one of the angles?
Yes.
We do. It was given to us, right? So that was one thing. What's our next step going to be? Yeah, so what we're going to say, angle what? Angle VWZ is congruent to what? Angle what? YWZ. Very good. And that's an angle, and that's what? Definition of...
Bisectors.
My F is really close. Definition of angle bisector. Okay? Third.
If there's ever an angle bisector, isn't the second one always definitely?
Not always the second. I mean, but that's generally the reason. Okay, third one. We have the angle. What do we need now, you guys?
Side.
The side. So what's the side going to be?
It's gonna be
WZ congruent to
WZ.
WZ. Or, Elijah, if you prefer, ZW congruent to ZW. Okay. And that is why? Reflexive. So now, ladies and gentlemen, you have got an angle, and a side. You have enough to say your statement down below. Therefore, the proof is done. Okay, the 5th and final way to prove 2 triangles are congruent work if and only if the triangles are right triangles. Right triangles mean that I'm guaranteed to have what in them? A right angle. Very good. That's this part right here. That's the right angle. Okay? If we go from the right angle and we go to the opposite side, which is this side over here, there's the name for the opposite side is called the hypotenuse.
Oh, is this a Pythagorean theorem?
Nope, not yet, but it's close. Hypotenuse, okay? The other 2 sides are called legs. Okay, so the yellow pieces, these are our legs right here. There's a leg there, there's a leg there. The blue piece is the hypotenuse. Alright? The hypotenuse is always the longest side because it's opposite the biggest angle, which in this case is 90 degrees. Always the longest side, and it's always across from the right angle there. Okay? There is something called, I'm going to show you now, called the HL theorem. HL theorem stands for hypotenuse leg. Yeah, we're not trying to be tricky here, right? We're not trying to be tricky with these the way we name them. Like, I didn't call this like the PR theorem. It stands for hypotenuse leg. It's HL, hypotenuse leg. Here's what it says. It's an if-then statement, and you can probably guess what it's going to be. If two, oh, sorry, not two. If, I'm so used to writing two. If the hypotenuse, and I'm going to abbreviate that by HYP, if the hypotenuse and a leg of one triangle are congruent to the corresponding parts of another triangle, another right triangle, then the triangles are congruent. The two triangles are congruent.